Every day, the sun delivers an endless supply of energy to our environment. And yet, it is only recently that we've realized just what a damaging effect our uncontrolled use of energy can have on our planet. We have to find ways of balancing our energy use with the need to minimize the harm that untapped carbon production has on climate change. In the UK, the government has already committed to legally binding targets on carbon reduction and has introduced tough legislation to help reduce the impact of energy use in the built environment. None more so than the Climate Change Act of 2008. But what if there was already a way to use energy more efficiently? What if we could take the energy provided by the sun and use it to deliver renewable heating where it is needed? And what if we could take heat energy rejected from one place and use it to deliver cooling or heating in another, in a kind of energy loop? The energy loop concept has already been recognized by the government, which has mapped out the untapped resource running through the heart of our communities, in the form of rivers and open water. In August 2014, the Department of Energy and Climate Change introduced a water source heat map of England to help illustrate the opportunities available for deploying innovative heat pump technology in the country's rivers and open water sources. This technology is now supported by the new Surface Water Heat Pump Code of Practice, which offers practical guidance and a set of minimum standards for this type of application, from inception to commissioning. This short film seeks to explain how the technology already exists to capitalize on this untapped energy, and to demonstrate how we can go beyond this by creating energy loops in buildings and within our cities to help maximize efficiencies, minimize waste, and reduce carbon. In the case of an open water energy loop, low-grade heat is harvested from the river or lake and upgraded using heat pump technology to deliver hot water and heating to a building. This upgraded heat can then be further enhanced at an apartment or office level to deliver full control and individual billing. This is already being used in London, where heating is being delivered to over 100 apartments built 200 metres from the River Thames. When the hotel alongside the development starts to operate, we will be able to see the full effect of a highly efficient energy loop, as the heat recovered from cooling hotel bedrooms is used to deliver hot water to the homes next door. By linking different types of buildings and energy use, the energy loop is capable of achieving a natural balance, significantly reducing carbon emissions through heat recovery. It's not just on a community scale that we can benefit from an energy loop. So let's look at some of the other advantages of using it within an existing building. Typically, a tall building contains a high-temperature riser, which is heavily insulated, yet still leaks heat into the corridors and lift shaft, often causing overheating in summer. The building is also likely to contain a boiler flue, which is also high temperature with a large diameter. To achieve cooling in a building, the chilled water or condenser loop is used to carry low-temperature water up and down the building. This rejected heat is often released into the atmosphere and wasted. With a single energy loop, we can remove the need for a high-temperature riser, remove the need for a boiler flue, and use a re-engineered chilled water riser to meet all of the heating, cooling, and hot water requirements using heat pump technology. Individual circuits can join to this energy loop to add or extract heat from it, giving us a more balanced use of technology throughout the building. To grasp how this works, we need to understand that the byproduct of heating is cooling, and vice versa. So, if we can capture this byproduct, we can use it in other parts of a building, community, or a district, increasing efficiency. There are many benefits of such a system, as it can balance the use of energy in buildings by recovering energy between areas that need cooling, such as server rooms and hotel bedrooms, with areas that need heating, such as apartments or hot water supplies. Once we understand the concept of the energy loop, it is clear to see that it is just as easy to use energy from rivers or lakes as it is from high-temperature district heating systems, CHP, boilers, or anywhere with rejected heat, yet still deliver full autonomy and control within individual systems and buildings. We can also add to this energy loop from many different external sources, as highlighted in the 2013 policy document, The Future of Heating. So, whether we harvest low-grade heat from industrial processes, or cooling server rooms and hotels, or even from open water sources, we can capture this energy and reuse it to reduce overall consumption and emissions. It's all about combining the heating and cooling requirement to form a coherent strategy, where heat is always recovered. Ultimately, this is the key to reducing carbon emissions.